So tonight I'm going to get into Unit 4 on exception handling, which is an interesting topic. It's one of those things where it feels kind of like, well, I could probably work just fine creating programs for myself without ever doing exception handling, and just let the program crash if something goes wrong, and I'll look at the exception and see what it was and fix it and rerun it. Yeah, but when you get out and you're working for somebody and they're paying you to write code that they're going to give to customers or end users that aren't programmers, then they don't like to see a bunch of hexadecimal stuff on the screen. It kind of makes them feel like, wait a minute, what am I paying these programmers for? So exception handling is one of those things that we like to do to gracefully handle the exceptions, is maybe the way we should introduce this. The exceptions typically will get handled, however, in an ungraceful way, and we want to handle them gracefully in a way that's more pleasing to the folks that are using our program. So that's what this is going to be about. So there's a class in .NET called exception. Same in Java. Java has an exception class. C++ has an exception class. It's a pattern that most modern object-oriented languages follow, defining an exception class, and they expect you to derive your exceptions from it. Another thing to realize too is underneath your program, the operating system is written in such a way that it defines exceptions, throws exceptions, handles exceptions, and when something happens, I guess the best example of this, the most frequent one that you will run into is with the file system. If you're opening files, closing files, reading, writing to files, then there are a whole bunch of exceptions under the umbrella of file I/O, and the operating system will throw those and they will bubble up to your application, and then your application will have to handle those. Even though you never defined the exception, you have no control over where the exception got thrown because it's in the operating system, but your application will have to handle the exception and do something with it. So we'll get into that too. So handling it involves wrapping code in a try-catch block, typically, is what we refer to it as, although it takes many forms. Similar to, you have an if statement, if else if, else if, then this has similar forms. It's going to look very familiar to you if you're used to coding the nested ifs and things like that we're familiar with. I'm also going to introduce something else that you wouldn't find this in the textbook or anything else, but again, if you go out there and you get a job in a commercial environment, they're going to probably also add to their programs or import into their applications a logging framework. And it used to be you would have to handle your exceptions and then come up with some kind of a clever way to log the errors or present the errors to the user that occurred, give them a choice to retry or cancel or exit, whatever, in a graceful way. But this stuff has been around for decades, and so there are several major logging frameworks out there that are popular, and we might as well learn how to use one in case that's the one that the company that you go to work for is using. You'll already be familiar with it, and even if not, the other ones are going to do the same thing. They're just going to use different names. The TryParse is another pattern that's really nice to use. We've already kind of talked about stuff like this a little bit back when we did the defining what you can return from a function, but I'll get into that later. I want you to know how to trace when you're debugging your application and an exception gets thrown, because one of the standard modes that you can run the debugger in is, I don't have any breakpoints set, just run, but when you hit an exception, please stop where the exception gets caught so that I can examine it and see what happened there. And then we want to be able to define our own exception classes, so we'll talk about that a little bit. And then what to do if you receive you catch an exception, but you don't want to handle it yourself. You just want to throw it back onto the pile and let the next layer up deal with it, which is a common, I wouldn't call it terribly common, but you definitely only want to catch try to handle the exceptions that you feel comfortable and know how to handle, and anything else, let somebody else deal with it. Not everything is your responsibility, I guess, in other words. You only want to have your application take responsibility for the things that you should or that you are responsible for. So what is it? Well, we call it logically something that happens unexpectedly. However, if we're anticipating it and we're creating an exception class that encapsulates it, is it really unexpected? Or after a while it can start feeling like, well, these aren't really unexpected events. They're just things that we know can happen once in a while, and we're creating a pattern for dealing with it. But I don't know. Depends on, maybe it's just semantics. So there's lots of different reasons. There doesn't even have to be some kind of a serious hardware or network or some kind of an issue. You could just define your logic to say, I want to call this function. The function accepts a parameter with values from 1 to 10, but you passed 11, so I'm going to throw an exception. We could completely make it the most transparent, shallow, surface level logic errors. We could throw exceptions to handle it, as long as the rest of our code knows that that's possible, and we can write the code to handle it. If you, obviously all the code that we've been writing, in the beginning class and up to this point in this class, you haven't written try-catch blocks necessarily, and haven't defined your own custom exceptions. So we've never addressed this before. What happened in all that time and all those programs that we wrote? Well, anytime that the application is running and either it calls something in the subsystem beneath it, or in the course of its own, you maybe divide by 0 or something like that, something exceptionable happens, then your program will terminate. So if you're running it at the command line, you'll see a bunch of blob text put out on the screen, followed by a command prompt. Your program exited. Same with the Windows application. You'll get some pop-up that says unhandled exception occurred, some text, maybe a location, hit OK to terminate. And you'll hit OK and boom, your application's gone. It just exited ungracefully. If you had a file open at the time, or a network port open, or you're connected to the database in the middle of a multi-step transaction, sorry, you just left the system in a bad state. So we want to try to avoid our programs exiting ungracefully like that. So we define these exceptions, and we follow the accepted pattern for handling them, catching them, in other words, and then dealing with them. So if you have code underneath you in the subsystem and the operating system that throws an exception, you'll typically get an object back that encapsulates that. What's it going to have? It's going to have some text that says, hey, don't write to this file when it's not open, or don't divide by 0, or I only expected values from 1 to 10 and you passed me 11, don't do that. It's going to summarize what the error is if it's a nice exception, and then some other stuff about where the exception occurred, and we'll get into that. But you'll get some data back when the exception occurs to help you figure out what happened and to support the error messaging that will follow. There's a bunch of these already defined. Very commonly, you will be writing your program and you'll realize that you don't have to create a custom exception class for what happened in your program, because of the dozens and dozens of existing ones, there's one that already exists that you could just throw that exception. So that's kind of nice. Like in the case we were talking about where the program or the function expects 1 through 10, but you passed it 11, well, there's an illegal argument exception. Oh, well, I'll just throw a legal argument exception and give it a little string that says, don't pass me anything outside of 1 to 10, and you're done. That's all you had to do. And you should use those. If you find one close enough to serve your purpose, you should use those because we don't want our code to bloat. And as soon as you create a custom exception class, at that moment, there's a new exception that's possible, but nobody has written any code to handle that exception, so nobody is expecting it. If you pick something like a common one, like an illegal argument exception or similar, maybe there's at least a chance, since that already existed in .NET, that people are already asking, hey, if I pass you this data and you didn't expect it or it's invalid, I'll put it inside a try catch and maybe I'll get back in the legal argument exception. You don't know how they coded their program, but it's possible. But when you create a custom class, you know that there's nobody out there expecting that exception. So when you find one that applies, you should always try to use it instead of creating a custom one. So what are common exceptions? Well, as I said before, we start with the base exception class. And it's even higher than that. We already know that all .NET objects inherently, implicitly are derived from system.object. So essentially it's system.object, then exception, and then there is a fork there where we can either have system exceptions or application exceptions. Now, Microsoft will tell you don't ever derive a new exception from system exception. You can look through all of the existing. I've listed some of the ones that stuck out to me because maybe I've used them before or I could see using them. So you see them listed here. But the idea is that the people writing the operating system have created a wide range of system level exceptions that apply to the kind of code that you would expect to be in the operating system. And if you were to create your own classes derived from system exception, you're just kind of misleading people because you're not the operating system. So why would your application be throwing something that derived from system exception? As we learned with the polymorphism, the level of abstraction that we can support with object-oriented programming means that perhaps some application out there has their try-catch handlers set up such that they do one thing for any exception derived from system exception and something else for anything derived from application exception. So if you derive your class, even though it's at the application level, if you derive it from system exception, you're going to get handled by that one and you might be misleading people. It's just, we could probably, nobody's going to go to jail or, get sanctioned or lose their programming license if you do this. It's just, this is the pattern. This is the recommended thing to follow as a .NET programmer. So just try to conform. Now, when I was learning .NET and for the decade following that, I was told any exceptions that I create inside my own application, any custom exceptions, I should derive them from application exception because that's what they are. However, now the recommendation seems to be don't do that. Don't derive your exceptions from application exception because apparently Microsoft has said, yeah, we have this other fork, this group of exceptions that are derived from application exception, but they're kind of our exceptions, and you'll actually be misleading people if you derive from that too, just like you would if you derived from system exception. So we just don't recommend you do that anymore. So that's changed in recent years. I don't know, 3 years ago, 5 years ago, 2 years ago. I don't know when it changed. But when you go read the MSDN documentation now, they say, yeah, don't do that. Don't derive it from application exception. Just derive it from exception. So you'll have your own custom exceptions derived from exception. And that way the stuff that's under each of these two existing umbrellas will stay under those existing umbrellas. Again, is anybody gonna, chastise you if you do it? Probably not. But it's just the recommendation at this point. Any questions about that? Make sense? You can, so figure out a way, a technique. I used to have a way, I've forgotten what it was, where I could go out and find the list of classes derived from system exception, so that if I needed to throw an exception, I could look at the list and see if there's one or which one fits my scenario so that I could throw it. Like if somebody passes you a reference to an object and you are not expecting it to be null and it is null, you just want to throw a new null reference exception. You don't want to create your own custom one. But you need to look through the list and find it. So, bookmark a Google search for, .NET system exception, something, but where you can go out and find this list quickly when you need it, so that you can just scan it and say, oh, there's the exception that I want to throw, and move on. Make sense? Okay. So how do we throw an exception? So I've got this cheesy little piece of code here, and I'm going to ask for how many miles did you drive, how many gallons of gas did you consume, and I'm going to divide the miles driven by the gallons of gas and print here's how many miles per gallon. Easy cheesy. You probably did something like this in COP 1000. But this code could throw exceptions, right? So if gallons of gas, for example, if they enter 0, then we're going to do a divide by 0 here. And if that happens, this program would just exit, right? Unceremoniously. So here's the example with no exception logic, similar to what we would have turned in before learning about exception handling. So I enter 300, gallons 12. This is the happy path. You might have heard me use that term before, but you implement the program and then you run it and it follows the happy path. You got valid values for each of your expected inputs. It performs the calculation and outputs what was expected. The unhappy path is they enter a valid number for miles driven, they enter 0 for this, and your program outputs unhandled exception, divide by 0 exception, attempt to divide by 0 at, and it gives you a location. This is the method, or the function, where the exception occurred. That way you as a software developer, you can think, oh, now I know exactly where to go in the code to see what the heck did I do wrong where I allowed this exception to occur. It says unhandled exception because we don't have any try-catch, we don't have any handler set up to catch a divide by 0 exception or any of its base classes. So poof, it says unhandled. So I would have said, I almost said, the operating system handles it for you since the application stack didn't handle it itself. But actually in this case, since it's a .NET application, we would say the .NET runtime failed to, or handled the exception because your application failed to. And same in Java, we would say the Java runtime environment handled the exception because your application didn't. If it's C++, we don't have a runtime environment that it's running in. It's just running directly against the Win32 APIs. And so we would say the operating system had to handle it when your C++ program didn't. See how that works? In other words, the .NET runtime environment has an exception handler that catches all unhandled exceptions from your application. So it's not magic. They just said, you know what, We don't want it to bubble up. And like, for example, we don't want the .NET runtime to crash just because one of the applications running on top of it had an unhandled exception. So we're going to catch all those and handle them by, just like this, printing, hey, you had an unhandled exception, don't do that. So, pretty interesting. Okay, so the try catch or try block, like I said with the nested if stuff, similar. We have lots of different forms that it can take. And over here on the right, you can see an example of what we're talking about here. We have a try block, and we put a bunch of statements inside the try block that we suspect could throw an exception. The one thing I will say about this, as it says, we want our program to be robust and fault tolerant. So when we introduce this topic, typically many developers will say, well, great, I'm going to put every line of code inside a try block. There's actually no reason to do that. What you should do is be cognizant of the code that you are executing. If you're declaring a variable, an integer variable, and assigning it to 0, there's no way that can throw an exception. So don't put it inside a try block for that, just by itself. But if you're going to say file.open and pass it a string as a file name, there are many ways that could throw an exception. The string could be empty, the string could be valid but point to a file that doesn't exist or no longer exists. We can imagine any number of scenarios. So something like file.open, we're going to put it inside a try block. Make sense? Don't just whole hog put everything inside try blocks like you will see some people do. Because if you think about it, that's only slightly better than letting the .NET runtime handle it. You're just dumbly letting one big try block process all possible errors, imagined and unimagined. Well, you've already got one of those. You've got the unhandled exception handler in the .NET runtime. So you're not adding any value. The only reason why you need to have a try block is A, you're calling something that you suspect or believe or know can throw an exception, and you feel confident that if you caught that exception, you'd be able to handle it appropriately. There's also another appropriateness check you want to do on yourself, where if you have function A that calls function B that calls function C that calls file.open, which one of those functions should have the try catch block? Well, the one most likely to know how to handle it and give the user a chance to recover, right? Maybe it's function A all the way at the top, in which case you don't want to wrap the call from B to C in a try block. You don't want to wrap the call from C to D in a call block. You want to wait until the function calls file.open, the exception occurs, and bubbles all the way back up to A, and its try block catches the exception and handles it, right? See what I'm saying? We don't want to just blanket put everything in try catch blocks everywhere. That would be wasteful. And there is a price to be paid, minimal though it is, for setting your program up to try and catch things. It's mainly in terms of stack space and maybe a few processor cycles. So it's just a small tax, but if we're doing it everywhere and functions that are called repeatedly inside loops or in a web server where you have multiple threads and hundreds of requests coming in, that tax could start to add up. So use them judiciously, but there they are. So what this is saying is, the code that's inside the try block, something gets called that can throw an exception. This is the appropriate place to catch it. Here's the syntax for how we would catch it. We say catch, and inside the parentheses, it looks like an argument, right? It looks like a function parameter. But we give the name of the type, or I will say the name of the base class where we want to catch that, and all derived. So if we said catch application exception, we're going to catch application exception and any classes derived from it. right? Same with system exception. If we say catch system exception, we're going to catch system exceptions and anything derived from that, okay? The E is a variable. You'll see lots of code where they don't even give the parameter a name, they just list the type there. That's because they don't plan on using the variable inside the catch block. But I typically always add a parameter name to this because I typically always want to reference the variable. When we get to looking at how to trace these, it also becomes important because, at least in the old days, the debugger wouldn't show you the value of the parameter if it didn't have a name. So, anyway. So perhaps we issue an error message or we log the error occurred or something, and maybe we exit the application still because we're in an untenable position. You know, if it was truly unexpected, how did I get here? This was never supposed to happen. I better get out of Dodge. Maybe you do exit, maybe you don't. And then finally, at the end, you may or you may not have a finally block. The reason why you would have a finally block is if you have code here that needs to run regardless of whether it hit an exception or not. So the code execution in the happy path is it's going to come in here, open the file, read the file, place the file, calculate, display, and then run anything in the finally block. That's the happy path. So the stuff in the finally block always runs. Okay, the unhappy path is open the file, read the file, blah, blah, blah. Something in here, we throw an exception, or the code that we call throws an exception. It bubbles up, you'll hear that term, the exception bubbles up to here, our catch block gets called, it executes the code inside the catch block, and then it executes the code in the finally block. Okay, so in either the happy path or the unhappy path, the code in the finally block always closes, or always gets called. And that's to handle situations where that's one of the reasons why this pattern was initially envisioned, is the try-catch pattern, is because when we're dealing with code that is managing resources such as file handles or network ports or blocks of memory that need to be freed, you want some code that when an exception that was unexpected for which we are handling it, we want the opportunity to free up or release those resources before we bail out. And that's what this pattern supports. Code that we suspect, code that gets executed if something bad happens, and then code that executes at the end whether or not an exception happens. Any questions? So obviously over here on the left we see number of patterns. We can have multiple of these catch blocks, one right after the other. Another thing that I'll point out is it just does a straight, it's like a nested if statement. It'll check each catch block, and if the catch block applies, then we're done looking. I found the code that's designated to handle this exception. I'm going to process those lines of code, and then I'm going to jump down to the finally. Okay, so if I have, and so you want to organize these in that order, anticipating that it's going to, like a Pachinko machine, bubble down through these things, find the one that applies, execute it, and then head to the finally. So I would generally recommend, therefore, that you want to make your catch blocks, you want to list them in order from most specific to most general, so that it hits the code that you want it to hit. Like if I had application exception first, and then all of the other exceptions that I define that are derived from application exception later, when it hits application exception, it's going to execute the code in there and never get to my other catch blocks. It just can't. It's like dead code. So that's just how it works. Any questions? Okay. All right, handling them. Great. We've thrown an exception. We've caught it. Now what are we going to do with it? So we have a number of pieces of data, as I mentioned, available to us when we are holding an exception that got thrown. That would be this E variable. So now we're talking about what to do inside this catch block. So we've got this E thing. What do we do with it? Well, we could call E.toString. So every, going back up to system.object, every system.object has a toString. Well, all of these exceptions implement toString. System exception, application exception, your exception, you'll want a toString function, and they will produce a string that represents, let's say, a summary of this. The base classes, I think they typically, so one of the properties of these exceptions that get defined is a field called message. It's just a string, and toString, I think by default just returns the message property. So there you go. But you can define yours to return anything you want to. You could add the date and time to it. You could add a record number, a file name, whatever you want that's applicable to your exception situation. You can put that data in there so that the code that catches that exception has it available, and they can process it if they want to, add it to a log, print it to a file, output it to the console, whatever they want to do. We also, all system.object derived classes have a get type, and it just returns the class name of the object. So we have access to that. We say, null reference exception, the name of the class is, a useful name. One of the other, we'll get to this, but one of the other conventions that is recommended for all exception classes is they end with the word exception. So null reference exception, illegal argument exception, my silly exception, whatever you're going to create, you end it with the name exception. That way, it's sort of like a self-documenting technique where anybody looking at your code will know, oh, you created this class for the purposes of making it an exception class. We also have a call stack. One of the things that happens when an exception gets thrown is it copies a representation of the call stack into the exception, so that can be interrogated. It's a collection object, and each item in the collection is a function in the nesting tree, so that you could walk up and say, okay, function A called function B, called function C, which called file.open, and you can track the path. This is actually very helpful because often, in my experience, when there's a really hard to find, hard to isolate bug, it's in a function that gets called from many different places, and you don't know which one of those callers was responsible for setting up the scenario that caused this function to throw an exception. And so being able to walk back up that, often that function itself doesn't contain the bug. Often it's whoever called it or whoever called that, something up the chain that created the situation that caused the exception to get thrown. And so in order to isolate the problem, it's imperative to be able to walk up that call stack. So it's very helpful. Then what do we do? Well, anything you want to do in C#. Like I said, you could print stuff to the console, you could pop up a message box, you could write something to a database, you could do other stuff. You could change, I had a divide by zero exception. Well, maybe I'll change the zero to something else to allow the code to continue, or otherwise fix the logical problem that caused this issue, perhaps. Whatever you think is fine. You could write code in there that does that. One of the things that I will caution you about is don't write a bunch of code in the catch block in general anyway. You want it to be short and sweet, what you do in there, if possible. Don't call a bunch of other functions. Don't make system function calls unless they're part of fixing the situation, because you want to avoid catching an exception and executing code that itself throws another exception. That would be a bad thing. So as much as possible, try to write unrisky code inside your catch block. And then again, you might be in a situation where you catch an exception and you think, well, I can handle these scenarios, and logically you have an if statement to determine if it's one of the reasons that exception could get thrown that you can handle. But then you might realize, oh, wait a minute, this is one of those situations I can't handle it, and I want to pass it on down the normal exception handling process and see if somebody else is more appropriate to handle it than me. So the pattern is, you don't just say, well, I'm going to create a new instance of an exception object and I'm going to throw that like you would, typically. You want to rethrow the exception that you were passed. And there's a really important reason for that. Like I said, often it's really important and really valuable when you get the call stack that you were processed in order to determine and isolate where the problem happened, or what caused the problem, the root cause. So if you throw a new exception, you just lost the call stack that you were passed. You're saying, I'm going to throw you an exception, but I'm not going to give you any of that information that was helpful for me. I'm going to make you start from scratch without any of that. So when you rethrow it, you're basically saying what this scenario I set up was, where, well, I thought I could handle it possibly, but I can't. So I'm going to let the normal process continue and see if somebody else more appropriate can handle the exception, but I'm not going to destroy any of the information that exists to make it helpful in finding out. Okay, so don't throw a new, different exception, just rethrow the one that you've got. I mean, there is another way of doing it. You could throw a new exception, but in the creation and the constructor of that new exception, pass it the call stack, or pass it a reference to this exception as the inner exception. So you're basically taking the one that you got and you're wrapping an extra context around it and then passing it down the line. That's a perfectly valid pattern. Any questions about that? I know it's a little abstract without seeing an example, but it is what it is. Yeah, like I said, we're not the first people that have done this. These patterns have been created. They've been refined over many years. Frameworks have fallen out of fashion, and new ones have come along to replace it. Typically, when you go to work at a company, they will already be using one of these frameworks, and they won't want you to buck the system and use your own. They won't want you to write code that doesn't use it. They'll want you to just kind of step in and start following the patterns that their existing developers and their code already uses. So you'll be aware of it now. You can look for it and just follow along with whatever pattern that they have you do. So some of the common ones that I've seen, there's probably a dozen others, I don't know. It's been a while since I did an exhaustive search. I haven't used Serilog, I haven't used PostSharp. I have used Log4net. Log4net is, I think Log4j came along first, and the .NET folks said, that's a really good idea. We really like that pattern. And so they created Log4net as a gateway drug to the Java developer so that they could follow their same pattern just in .NET. So Log4net and Log4j are very similar. So I wanted to do an example and show you some of this stuff, less abstract, more concrete, and show you an example of using this so you can see kind of how it works. There's a few things that you have to do in your .NET project, similar to last time when we talked about the AI. This is just the pattern that you follow when you're adding a library or a module to your C# project that you then want to use. We're utilizing other people's code. Log4net is other people's code. We want to pull it into our project and be able to use it in our code. So the first thing you need to do is you need to go to NuGet, however you want to install packages into your project, and you install the Log4net. You search for it, click install, boom, Visual Studio adds it to all the appropriate references and configurations so that your project has the binaries that it's dependent on and hooks up the references in your solution in your project. Next is it requires a configuration file, so you'll need to create this log4net.config file, and it's got some stuff in it. I'll show you the example of that. And you stick that in the root of your C# project so that it can be found. It's very important, though, whenever you add files like this to your project, you have to right-click on it and say, or look at the properties of it over in the little window on the right, and set to copy this file to the output directory. It's like a build step. When you build this project and you create the exe over here, take this log4net config file and also copy that to the folder where you put the binaries. Otherwise, you'll have a perfectly valid config file in your project, and you'll have a nice built exe over here, and when you run the exe, there's no configuration for the logging, so it'll all be disabled. You won't get any logging. So you don't get any build errors, you don't get any warnings, you just don't get any logging. So if you set this property and tell it to copy to the output directory in Visual Studio, then when it builds the exe, it'll also copy the file out there. So when you run the exe, it says, oh, looky there, a logging configuration file, and it'll open up and follow your instructions. Next is in my class, in my program class, I'm going to create an instance of a logger object. Great. Now my code has access to a running instance of an object. Then in your main function, that's where you'll execute the line of code that says, go read that logging configuration file and set up the properties of that object to use that configuration. Then you're going to add a bunch of trace messages to your code in your catch blocks or other places, and any exceptions that occur, you'll want to, write log data appropriately. Okay? So yeah, let's go look at that. So here's Visual Studio. Hopefully that's big enough that you can kind of sort of see it. Okay. I already created this, but it's just a console application, just for purposes of simplicity. And here's my, solution at the top, my project underneath that, and underneath here I have a program.cs file and a number format exception.cs and a log4net.config. So let's do the properties of that log4net.config, and see down here it says copy if newer. So you can say do not copy, which is the default, copy always, or you can say copy if newer. Copy always and copy if newer for this log4j or log4net config file. You can use either one of them basically. Copy if newer is probably just going to be slightly faster to compile is the only difference. But, so this one's set to copy if newer already. Let's look at what's in this config file briefly. I'll go down here to the bottom. This is the top level config in this root node. Level value equals info. So there's info, warning, error. You can, if I set this to error, I'm not going to get any logging for anything less severe than an error. Okay, if I set it to warning, and I don't remember whether it's warn or warning. I think it's warning. You might have to check me on that. But now I will get anything that's marked as a warning or an error. When it's set to info, I will get any informational messages and any warnings and any errors. So you see how it's stacked like that. So if you're in production, you might have it set to only do errors or only warnings and errors. But if you're on your developer machine, you want to see the verbose logging so that you can monitor everything that's happening in your program as you're writing your code and editing your code. That's typically what people do. What are these? So I have two what we call appenders. In Log4Net, they call them appenders. And here I'm just referencing the ones that I've defined. So maybe I don't have any appenders, but in this case I have a console appender and a rolling log file appender. The console appender is going to be set up to output to the console, and the other one is going to create a log file. And anybody ever heard of a rolling log file? What it does is it says, I'm going to define a limit on how big this log file can grow. You know, there have been websites that have done what they thought was a really good job of handling exceptions and logging appropriate information to the log. And they run for a couple of hours and then the web server crashes. And they finally figure out why their web servers keep crashing after a while. And it turns out that their hard drives on their machines are full because the log file grew to exceed the capacity of the storage that they had on the web server. Okay, so you can either then bump down the level or the verbosity of the log information that you're capturing, or you can go to a rolling log file. So a rolling log file, you say, here's the maximum size of this log that I want it to ever grow to. And when it does, it starts overwriting the oldest messages. So it only keeps like the tail, the newest so many messages to not exceed that maximum file size. So anyway, so then these two blocks here, this is just configuration information for the rolling log file, and this is configuration for the console appender. You know, you can change what format you want the messages to the console to look like, what information you want them to contain. You know, you can set the maximum size of your rolling log files, how many of them, you know, etc. What gets put in the rolling log file, all of that stuff. And you can, the good thing is you can create a whole bunch of these appenders, you know, a dozen of them if you want to. And then down here in the root, you can say, and I want you also to use these, just these, you know. Like maybe in production, you don't want to print stuff to the console, but you still want to keep writing it to the log file. Okay, that's fair. But anyway, you use this file to configure the logs however you want them to be produced. And there are reams of documentation out here. This is just a brief overview on how these can be configured. Okay, so here we are in this main function. So the main function is going to, yeah, I just made this up. There's nothing special about this. The requirements of this, you know, I've got my hello world that I started with. I define a path to a file, and then I call this read and divide. And as you might imagine, the read and divide is going to read numbers from the file and do a division so that we can test the divide by 0. Okay? So here's the read and divide function. It receives the file name. Oh, cool. So before I even do anything, I'm going to put out a log message that says, here's the file that I'm attempting to read. File.read all text. That sounds suspiciously like one of those suspect functions that could throw exceptions. And let's see if, I haven't tried the F1 key here to see if it's configured, but do we not have, oh, I guess I have to do it this way. So I just hit F1 on this read all text. And the cool thing is that the .NET documentation tells you where it's defined, which DLL, blah, 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 what it does. But if I come down here, it has a section called exceptions. So turns out every .NET API method that you could have access to, it will list what exceptions could be thrown by calling this function and why, a little bit about it. That is incredibly valuable. Not many people use documentation anymore, but just like it's cool to have a list of all the exceptions handy that you can refer to, it's really nice to hit F1 on the function or Google the function and come out here and look at this list of exceptions that each function could throw. And, you know, it might not be unreasonable to put in a try-catch block and handle each one of these. So security, the file exists, but you don't have access to it. I can't do that. You know, maybe you gave it a Unix file name instead of a Windows file name or something. I don't know. But you can read the names of these exceptions and anticipate perhaps what scenarios, or imagine what scenarios might arise that causes that to get thrown. So very useful. I recommend you start your journey of learning more about the API functions that you're calling. Okay, so I read all the data from the file. I parse the contents of the file into an integer. You know, my comment says that might throw a format exception in addition to all the things that read all text might throw. Then int.parse could throw a format exception. Then I'm going to do the division, which perhaps I divide by 0, so it could throw a divide by 0 exception. Notice that this isn't a function call. It's just performing an operation, a division operation followed by an assignment. And the division operation can throw a divide by 0 exception. Probably wouldn't throw an illegal argument exception, but it could throw a divide by 0 exception. And then I do a console write line, and then I do another log step that says, by the way, this worked, and here's the result that I got from it. Just informational log messages to show you an example. So that's my try block. Below is the catch list, the list of all the exceptions that I'm catching. File not found exception, format exception, divide by 0 exception, etc. And I've got a variety of examples here that you can look at for how I handle it. So the first one we're going to look at is this file not found exception, because I don't have a file. So if I run this program, it's not going to be able to find a file because I have never created one. So let's see what happens if I run my program. Okay. So I got hello world. My console appender logger has put out this informational message saying attempting to read file number, which is right here. So that's what that looks like on the console when it calls that log. The next one I get is error file not found. Where did that come from? File not found exception. Look at that, log error file not found. And then this is the message text That's the message property of the file not found exception. So anytime you catch a file not found exception and you look at the message property of that exception object, it's going to have a string that looks something like this. Could not find file. It's going to give you the file name that it tried to find. You know, that's useful because often you'll say, oh, dang, I had a typo in the file name, or somebody entered the wrong file name. That's why this happened. And then it's got some more stuff repeated. And then here's the call stack. So it called create file, called open, called a constructor, you know, this is the call tree. And then another error file not found, a lot of duplication of stuff here. Okay, then we get this operation complete. Where'd that come from? Well, if I look down here in the finally block, like I said, even when you catch an exception, it's still going to call the code in here. It says operation complete, operation complete. So you see, we've got a lot of duplication in here. I don't really need so much these messages. You know, I really only need one or the other. This is just a cheesy little console application, so I'm not going to worry too much about the design of it. But this does seem a little redundant, doesn't it? But one is coming from the log, hitting the console logger and outputting the message to the console, and the other one is from my console write line that I coded. So I could probably clean that up a little, getting rid of one or the other. See how that works? Pretty clever? Okie dokie. Okay, moving on to the TryParse. So back when we were talking about advanced method handling or method definition, we talked about how when we're defining a function, we can have a function return a variety of things. We can have a function defined that returns nothing, in which case we define it as void, right? We can have a function return one thing, so then the return type is whatever we're going to return, an int, a string, a float, whatever we're going to do. And then we can have our function defined to return multiple things. In C#, what we typically do then is one of two things. We've got multiple methods available to us. One is we could define out parameters in the argument list, like this one, where we define a variable in the calling function. We pass that out parameter to the function, and it has permission to set the value of that to something when it returns back. So since it's in an argument list where we can define multiple out parameters, that automatically gives us the ability to return multiple pieces of data. Or we could define a class and we could return the class, and we could put all the multiple pieces of data in the class that we want the function to be able to return. So we've got a couple of different options there. Well, this follows that returning multiple pieces of data pattern, in that we're calling a method, we want to get a piece of data back, and we also want to get the success or failure indication. Were you able to do what I asked you to do so that the data you returned me is usable and reliable? Or did you hit a scenario where you weren't able to accomplish that and I should ignore what you returned? That's basically the pattern that we're following here. So TryParse, we have to do this often enough that we just created this common pattern for this function, TryParse, and there's a TryParse set up for int, for float, for a variety of different data types that we can support, and you can create stuff of your own. TryParse name, where You look for a last name, comma, first name format. And did it work? Nope, it was missing a comma, so I was unable to do it. So maybe you return false. The idea of this is that we're trying to do this without having to wrap the code in a try catch. Because I don't know if you noticed, but the code where we're doing all this try catch stuff, it gets pretty verbose. We're racking up a lot of lines of code when we do that. A lot of curly braces, a lot of, just a lot of lines of code. It's not what you would call a compact pattern of producing source code. So if we have this TryParse, it lets us go back to a pattern in the code that's calling it, where I just call it. It's like a fire and forget. And I can just check the return to see if it's true or false to see, I don't have to put it in a try-catch block. The try-catch block is inside the function, and it's going to return false if it catches any kind of an unhandled or an exception. Okay, so this code that you see here is the typical implementation of a TryParse. So if you were going to create your own TryParse name, you would pass it a string, and you might have two out parameters, first name and last name, and you would follow this pattern. You'd try, instead of convert to int32, you'd try parsing the string, looking for the comma, and splitting up the first half and the last half, and setting the two out parameters and returning true. So anyway, so I wanted you to see that it applies. We've probably seen this before. You may have even written code to call this before, but it fits in the conversation of the try-catch pattern. It's a way to make our code look a little bit more elegant, but it employs a try-catch block itself in order to do that. Okay, next thing I wanted to show you is tracing the exception. So in my code here, I just ran it. I didn't put any breakpoints. I didn't step through the code, but I want to remedy that now. I'm going to set I know it's going to still throw the file not found exception, so I'm going to set a breakpoint over here on this message. That way when I run it and it throws the exception, gets caught by this block, it'll stop here and we can look at some stuff. Okay, so it did it. I'm looking at hello world and attempted to read number. Not much has happened yet. It got down in here and tried to do some stuff, and boom, it threw the exception, right? So I'm sitting, I haven't logged that the file wasn't found yet or anything. That wasn't my point. I just wanted to look at the variable. So I'm going to look down here in my automatics, and I see this EX. And I'm going to expand that a little bit. I'm sorry, you probably can't read that very well. You might have to try this on your own to look at it. I don't think I can make this window any bigger, so sorry about that. But I can describe it. Each of these exceptions is going to have some things that you can always anticipate because they either come from the base exception class or from system.object. So they're all going to have a toString. They're all going to have things like that. So all of your classes derived from exception are going to have a message property. And when I look at this one, it says could not find file, single quote, and the file name that it was passed. So great, I can see that. Another one that I want you to get in the habit of looking at is the inner exception property. This one says null, so there isn't an inner set of exceptions that bubbled up and was rethrown and bubbled up and rethrown and bubbled up and rethrown. There isn't on this particular one. It's a flat, hey, we quickly ran into an exception. There's no more complicated than that. The other thing I wanted to point out here is the call stack. So there's a dot stack trace property of the exception object that you can look at and process programmatically if you want to, in order to either programmatically determine how to handle this situation or to just spit it out in the log or to the screen, whatever you find appropriate. But you can see here, our program read and divide, right? Our program's got run. It called a function called read all text, which we know because we did that in our main function. Read all text, and notice now we're inside the .NET runtime. Read all text called validate arguments in open path. I don't know what choose strategy core is. Then it called a constructor of something. Then it got down to, now we're into the Win32 API. So now the .NET runtime code has left the .NET runtime and it's actually calling the Windows system code around files. So it's going to try to open a file handle, and then when it couldn't find one, it's going to call create file. Now, I've actually been in this code a little bit once or twice when I worked there, and it's kind of interesting how it works. It's weird that I said I want to read all the text of this file, and I got down in the bowels of the code and it's calling create file? No. But what create file is doing is saying, oh, you said try to create file, but create file is going to say, yeah, I'm not allowed to create a file here. You didn't ask me to create a file. You asked me to open a file. But it's common code. Anyway, long story short, this just happens to be where the exception got thrown. In the Win32, the Windows subsystem, it threw the exception. It said, yeah, you gave me a file path and that value, that file doesn't exist. Boom, it bubbles up to open. Open says, yep, throw it. Goes back to this constructor, go back to this. Comes back to read all text. And read all text says, I'm going to throw it back to the application. And our read and divide, and that's where we caught it. Okay? Just interesting to glimpse into the inner workings of how exceptions bubble back up. So like I said, very helpful in trying to isolate what happened and how to fix it is to interrogate, set a breakpoint inside the catch block and interrogate the properties of that exception object that got returned. Okay? And when I'm done looking at it, I can hit continue, and it continues and does the exact same thing that it would have had I not stopped on the breakpoint. So I didn't interrupt the flow, I just examined it as it was running. Okay? All right, so creating a custom exception, what does that look like? So it's pretty simple. Like I said before, in my day, we would have probably created a class and derived it from application exception, but nowadays they're recommending that you just create a class and derive it from exception. The other convention is that you end the name of the class with the word exception, like I said. You're going to create a constructor or one or more overloaded constructors. And in each of those, make sure the basic concern is make sure you call the base constructor. And you'll add your information to it. So a useful thing would be to add what's the purpose of your custom exception if not to communicate extra information about specifically what happened in your application. Yeah, and then somewhere you realize this issue has arisen, so you're going to throw the exception. There's a couple of ways that you can create a variable and assign it to a new instance of your exception object. And then you can throw that variable. That's what that would look like. Or what you'll see most commonly is people will just say throw new and the name of the exception class. So let's look at that in here. As you can see, I have a number format exception defined. And as advertised, name of the class, number format exception, and I derived it from exception. I have 3 constructors. It's overloaded, and remember overloaded means we're using the same name, but with different signatures. So I have different parameter sets. One of them I call with just nothing. So I should probably call base nothing. I think I don't do that because that happens anyway. Whenever you have a default constructor, it always calls the base constructor default. But now I'm doing it explicitly. I define an overloaded one that takes a message, and I pass that message. The base exception class has a constructor that accepts a string as the message. So I'm going to make mine call the bases so that I pass that message on. As you might guess, it does nothing more than setting its message property to the value you pass it. And then a third overloaded variant accepts the message and also an inner exception. So you would use this in the case where you are adding a layer of exceptionness to your exception that you received, so you can just pass it as a parameter. And again, as you might anticipate, it's going to call the base class and just pass along the inner exception. Very simple, very transparent, transparent what it's doing, what it's expecting, but that's what it looks like. Now we come back, now that the class exists, we come back in our program here, and so if I catch a format exception, let's say that the code found the program, or found the file that it was looking for. What was it? Number.txt. Let's say that number.txt exists, but when the program opens that file, it contains the word puppy instead of 17, It contains something that isn't the right format. Well then, when we try to, when we try to parse it, we're going to throw a format exception, because that's what parse does when you pass it something that it wasn't. Int.parse, when you pass it a string that doesn't contain a number, it throws a format exception. Okay, so that bubbles down here. It's not a file not found exception, so it skips that one. Falls into the format exception, and normally something like this would have happened. We would have logged it and wrote something to the console, but instead I commented those out and I said throw a new format exception. Here's my message: invalid number format encountered in input file. Sounds businessy. And then I pass the exception, the format exception that I received as a parameter, and that will now become the inner exception of my number format exception object instance. See how that works? So I'm going to throw my new format exception, but before it does, it's going to come down here and write this to the finally. So let's see if we can get that to occur. And if I just run this again, I'm going to get nothing other than the same output. Get rid of my breakpoint. So same thing, file not found exception. But let's see if we can get rid of that file not found exception. The simple way for me to do this is I'm going to come over here to my project. I'm going to add a new item. I'm going to call it, what was, my memory is so bad. What was the name of the number.txt? Okay. Add new item, number.txt. Okay. So here's the file. If I put 20 in the file and hit save. Now the same thing's going to happen as before. It's going to get file not found exception. Let's run it and prove that, yeah, see, no difference. File not found exception. But if I click on this and I say copy to the output if newer, and I rebuild it, let's go look and see open containing folder. Okay, so there's the source file. There's my log4net config file, the source file, program.cs. Got all of those files, my source files in here. But if I go to the bin debug, this is where it built and deposited all the output files. Now I have those two files here in the output folder. So I would expect that when I debug this again and it runs this exception handling.exe, it should, well, I know already that it can find the config file. So now it should also find the number.txt file, is my hope. So let's see if that occurs. Hey, look at that. Attempting to read file number.txt. 100 divided by 20 is 5. Calculation successful, operation complete, operation complete. So this looks like we successfully fixed the issue and we're on the happy path. Right? Excellent. But if I come over to number.txt and I change this to the word puppy and save it, I'll rebuild my program, which copies the file back out there since it's newer. I'm guessing that's going to generate a format exception. Yep. And the interesting thing about this is it didn't just dump the information to the screen and exit like I might have hoped that it would, but instead I got this pop-up, exception unhandled. I got a number format exception. It printed my string, right? This is my string. Right? All of this cool stuff. Here's the inner exception. So the format exception also says, it adds the string or the message, the input string puppy was not in a correct format. Thank you, format exception. Gives me the call stack. Where's this box coming from? It's not me throwing that pop-up, is it? Where did that come from? Well, what happens if my program throws an unhandled exception? Who gets next crack at it? The .NET runtime. Remember the .NET runtime environment. So this is what the .NET runtime environment does when a program throws an unhandled exception. I was like, well, wait a minute. How is it unhandled? It's happened inside my exception handler. And that's one of the insidious things. You have to be careful with this stuff. I'm doing something inside my catch block that is throwing an exception itself. That then becomes unhandled because the code that's calling read and divide does not have a try catch block. So thus it's unhandled. It bubbles up and says, well, nobody's handling it. .NET says, oh, this is an unhandled exception. Make sense? That's just how it works. So if I wanted to catch that, I could, again, I'm not going to put a try catch around everything in the main function. I don't need it. None of that stuff could throw an exception. And I hope you just saw what I did. It popped up the helper, and all I did was hit tab again, and it modified my code automatically. I think that's pretty darn cool. That's the, the AI feature of Visual Studio. This is all new stuff. I've never actually coded that before and been able to automatically have it fill in all that stuff. That's a new experience for me, although it doesn't surprise me knowing all the other places where AI logic is embedded nowadays. But it anticipated that I wanted to do this, except that it didn't finish. It makes mistakes too. It's not perfect. Okay, so here's my original call. I'm trying that. How did it automatically know this? Well, Visual Studio is smart enough to look at your code and realize that this is a reflection feature. You can ask functions about themselves and they will tell you what they will throw. And so .NET did that, and it said, well, looky there, this code could itself throw a number format exception. And where did it get this? Well, it's just mimicking what I did. So it says, well, this is what you did down here for your catch block, so why don't I do a similar thing? So that's how I would handle this now unhandled exception, is I would go to the calling function and I would put a try block there. Make sense? I didn't need that before because read and divide wasn't possible for it to throw any exceptions. I didn't have any code outside of the try block that would throw an exception until I wrote this line of code. Throwing an exception inside a catch block is now unhandled and goes to the caller, not this. I mean, you can nest them. I could have a try within a try. I could also do that, I guess. But, at a certain point it becomes a little absurd. Anyway, it's like anything else. Write the code so that you get the behavior you intend, not behavior you didn't expect. That whole thing about, well, my program is doing exactly what I told it to, but not what I wanted it to. Okay, have I beaten this to death yet? Can I move on, do you think? Okay, that's custom exceptions. So what we went over was, we talked about the exception class, what it is. We talked about how to handle exceptions or a variety of different exceptions as part of a chain. The different formats that you might see in a try, catch, finally block. We talked about logging frameworks, which is completely value add for you guys. Hopefully that helps. It'll stick in your head, and if you ever are getting paid to write code, you'll think, oh wait, there was some logging framework. TryParse, that pattern we revisited, how to trace it. I would get comfortable with setting breakpoints inside your catch blocks and looking to see what is in those objects. I guess if you're using a logging framework and you have good console write lines or other message boxes and things like that to help you see what's going on in your code, maybe you don't need to trace as much, but you need to get familiar with tracing anyway. Get comfortable with using that because it'll save your bacon. And then how to create our own custom exception classes and throw them, and then the whole rethrowing topic. Any questions? Awesome, fun stuff.